And we're doing 15 from page 2. So, yes. 16. Sure. So for number 4, we have to solve this, get A by itself, distribute first. Be careful with your negatives. And then this, I can already see that this is going to have the same coefficient, and these are going to be different, so it's going to give me no solution. But let's solve it regardless. If I were to move 7a by adding, if I only did that, I'd get 21 equals 11, which is no solution. But if I also move, let's say, 11 at the same time, I get 10 equals 0, which, again, is no solution. So regardless, that one is no solution. Questions on that one before we continue? For number 15, similar to 16, similar to perimeter problems. A larger number is 5 more than twice the smaller number. Twice a smaller number. Their sum is 80. Find the numbers. So you're defining the variables would be L for large, S for small. I'll write that just so you have it. The first sentence tells us about the larger number. Is 5 more than twice a smaller number? So L equals 5 more than is plus twice, so we're multiplying by 2 to S. And then in the next part it says their sum, the larger and smaller number's sum, if I added them together, would give us 80. Find the numbers, both the larger and the smaller. So we're going to take that equation for L, put it in where L is. So 5 plus 2S plus the S that was already there equals 80. And once you have your equation, solve. So combine your S's, add 2S and S to get 3S. Get rid of 5 by subtracting. And divide both sides by 3. What is S? What is 75 divided by 3? So that's one of our answers. Then we have to go back and find the larger number. You can either put 25 back in here for S or put it back in here. Does not matter which one, as long as you do one of them. Yes.
Does that say 3S, 5 plus 3S? Where did 3
Where's what?
We added 2 and 1. So then if we put 25, let's say, in for this L equation, Layla, whisper. This would be 50 plus 5. So L is 55. If we had units with this, we would put that, but in this case we're just looking for numbers in general, so we don't have to put units for that one. Questions on that one?
Which would the 2 from? And 5 plus 2S?
This 2,
Yeah.
or this one?
The first one.
This one?
No, the other one.
From this.
Or where's the half
Twice means we're multiplying by 2.
What does it say next to the S? S equals
25.
no, the first one.
Oh, small. Yes. Say again. Conjugate elegant. Put 25 in here. And simplify. Other questions there? You said two things. How did we get to, and what was the other thing? Okay.
How'd you get the numbers to set them up?
This 5 and this 2. And this 80. All the numbers were given to you. Other questions?
How do you know where to put the zeros? Where's our
Like in this one? In this one, because it's twice a smaller number, I'm multiplying.
Oh.
It didn't matter if I put that first or last. But if it was subtracting, then it would have to go in a certain order. Okay, on to the second one. As part of their government class, Maddie and Ryan had to log volunteer hours in their community. Ryan volunteered for one more than 3 times the number of hours that Maddie did. Altogether, they volunteered in the community for 45 hours. How many hours did Ryan volunteer for? So, we're going to set up something similar, but we're only looking for Ryan's number, not Maddie's number. So this first equation, or this first part is talking about Ryan's. So one more than, I'm adding 3 times the number Maddie did. I also need variables. So let's say I'm saying R and M for number of hours each volunteered. So anytime it's not larger, smaller, or length or width, you have to define your variables. So I have that part. And then altogether, similar to their sum, they both got a total of 45. So if I knew R and I knew M, I could add them together and get 45. So then just like the last one, I'm going to take R's equation and put it in where R is. Now, when we do this, we're going to find Maddie's number first and then have to go back and find Ryan's, which is fine. So
Does the 45 have to be in the order then?
it could have been at the end, it doesn't matter. Brennan?
How do you get 2 M's?
This one was already there.
Yeah.
This one was from this. So combine your like terms, start to solve for M. Get rid of 1 by subtracting. I don't really have space for this. 45, 44 equals 4M. And divide both sides by 4. The M would give us 11 hours. But we weren't looking for Maddie's hours, we were looking for Ryan's, so now we have to go back and find Ryan's. By either putting 11 in here and solving, or putting 11 in here and solving. It does not matter which one. I'm just going to use this one because I'm running out of space. So Ryan did 34 hours. And make sure you have labels as these are word problems. Questions on that? Other questions? Sure, and then we're not doing any more word problems after that. So 17, similar. A rectangle has a length 6 inches, less than twice its width. The perimeter of the rectangle is 54 inches. Find the dimensions. So this one, I don't need to define them. It's L and W, length and width. You could if you so choose. But I know this first part is talking about the length. L equals 6 inches less than, that's subtraction. Whatever comes before those words go at the end. So I know it's going to be minus 6. Twice its width, I'm multiplying 2 and W.
How come the 6 went? How come the 6 went?
Because in this case, this is saying it's like a turnaround phrase. Whatever comes before those words have to go to the end.
So that applies for every single problem.
For every less than problem, yes. Our perimeter we know is adding up all the sides, or for short, 2L plus 2W. If you wanted to just do P equals L plus W plus W, you could do that. You just don't have space on the paper to do that, so you'd have to get more paper. We could replace P with 54 and L with this equation. And then just like the last two, solve that equation, get whatever W is, and then go back and find L. So here we would combine our like terms, 4W and 2W, to get 6W. Get rid of 12 by adding. And divide both sides by 6. So that 11 inches, yes, is W. And that's one of our dimensions. But then we would go back and find L. By putting that in, you could do that here or here, does not matter. There we go. You could always go back and double check these, put them into the original, yes. Which one?
Page 3, number 2.
Page 3, number 2. Yes, we can do that. So in this one, we want to distribute. There is an invisible 1 here, so distribute the -1 and the 7 on the other side. So we get 11 minus 3x minus 1 equals 7x minus 42 plus 2. Combine your like terms on the same sides. So 11 minus 1, negative 42 and 2. I can tell that this is going to give me one solution because the coefficients aren't the same. Pick and choose what you want to move, does not matter. Let's say I get rid of 3x by adding and get rid of 40 by also adding. So we get 50 equals 10x and divide both sides by 10. So that x equals 5. Questions on that? Other questions? Yes.
Why isn't it like 33x?
For where?
For the first part, so 11 distributed into.
Because we're not distributing the 11, we're distributing the -1. Other questions, maybe for absolute value or literal? give you a second to look once more, and I'm going to explain how the quiz is going to work. So, as I mentioned before, that there is a non-calculator part and a calculator part. We're going to do the non-calculator part first. So in a moment, you're going to put your calculators up. When you finish the non-calculator part, you're going to turn it into the bin, and then I'll give you the second part. This quiz is collaborative, so you guys can work together. However, that doesn't mean copy down someone's answers, because I'll just take that quiz. Okay. So be explaining, how did you get this, talk to each other. Questions on how the quiz is going to work? Oh, you can't use me. You can't ask me questions. I'm not part of that collaborative, unless it's a clarifying question. No notes. You can talk to each other. You're going to start with the no calculator. Were there any other review questions you guys wanted to go over before you guys start? Yeah. Page 6, number what? So we're 14, you said? Yeah, okay. In 14, we're solving this for h. We have v equals pi r squared, h. Everything here is multiplying. To get h by itself, we would divide everything at the same time on both sides. Make sure you are doing things to both sides. Our properties of equality, we have to do it to both sides. So those cancel, leaving b. We would rewrite it, Mahar.
Could we do page 8 number 6?
Page 8, number 6. Still our literal equations. We're solving this for r. We gotta get rid of this single p by subtracting. And then I can get rid of p and t just like we did for the last problem. Divide everything at the same time. So these cancel, those cancel. So we have a minus p over pt as our final answer. Last question. Going back to the other literal. So in this one, we are solving for a. We need to get rid of 4b by subtracting. To the other side, those cancel. W minus 4b equals 7a. To get a by itself, divide both sides by 7. So those cancel, and we're left with c. B and C are similar, but one has only W dividing by 7, where the other has everything dividing by 7. So that matters. Okay. So I need desks cleared. If you have other questions after the quiz, you can ask about those or come see me after school today.